Hey, so I'm going to quickly show you the difference between the two types of Z tables, Z charts, Z score tables. We looked at one in class today. So this is sort of my preferred version, but both of them are telling you the same information. And so we're going to look at Z scores in both of them. So this first version, what it's telling you, for whatever Z score it tells you, it's how much, what proportion of the data of a distribution is to the left, is less than that Z-score. So for a Z-score of 0.1, 0.53, or in other words, just about 54% of the data is less than a Z-score of 0.1. The other version, which is in the textbook, I believe, and is on Brightspace, shows the area between the mean and the z-score. So for this kind over here, they're only positive, right? And so you sort of have to figure out if you have like a negative z-score, you have to figure out how to subtract it. So here's the idea. Let's go through a few really quick. So let's look at 0.31. Here it's 0.6217. If we look at, where's 0.31? If we look here, 0.31, 12.17. So you'll notice this one's also in percents instead of in proportions, which is fine. But if you just add 50%, so in other words, this is doing just taking this area right here. So from 50% up to the z-score, and it's just telling us what's there. And so if we want to figure out how much is less than that, then we have to say, okay, for 0.31, 50% plus 12%, so 62.17. And if we look over here, 62.17, it's exactly the same. Where this gets tricky is looking at the other side of it. And so if we want to, if we have, for example, negative 0.25 z-score, well, it's really easy if we come here, negative 0.2, 1, 2, 3, 4, 5, it's 40%, 40.1%. If we look at 0.25 z-score here, then we get 9.97. So in order to get to that 40.13, I think it should be 9.87, actually. I think that's a typo. In order to get there, we have to subtract that from 50. So in other words, instead of going to the right and adding 9.87 to 50, so we would get 58.7% is to the left, we have to take that 50% and subtract our 9.87, and then we end up getting whatever it is, 40.13%. And so, in other words, this is, because it's symmetrical, it works. So this type of z-score is just telling us how far we are from, what percent of the data is this far from the mean or farther. And if we need negative, then we just sort of flip that over and we think, okay, how much of it is on this side? I personally think that the second one is easier. You sort of always can work from the total, but either one is totally okay, and you should probably know how to do both. Hopefully that's helpful. Maybe we can do one more example. So if let's do a z-score of -1. So -1, we should have, right, if you think about it from our original, we know the standard distribution, we know that one standard deviation is about 34%. So we should subtract about 34%. We should get about 16%. So let's see if that's right. Yeah, 15.87% is what we get to the left of it. If we look it up in this other table, if we look at 1, let's see if we can find it. 1, it's telling us that 34%, right? So it's telling us how big that proportion is between the mean and the, so in other words, this area right here, between the mean and one standard deviation. It's telling us that is 34%. So if we wanted to get, let's say this z is -1, we know that this is 34%. We have to do 50 minus that 34% in order to get what we really want, if we want that, how much is less than z. And then always, we can do the reverse. Once we figured that out, that the, either way we figured out that this is about 16%. If we want to know how much is greater than that, we just do 100% minus that, or 1 minus the proportion, right? So 84% is what would be on the other side. Hopefully that is helpful, and this way we don't have to use class time to talk about this.